Hello, I welcome you all in this presentation related with the subject fundamentals of surface engineering, and we are talking about the surface modification techniques, and under these techniques basically we are talking about the methods which are based on changing the chemical composition of the surface layers, so that the improvement in surface properties can be achieved for improving the tribological behavior and wear resistance of the components. So, under this category the one last process about which we will be talking is the laser nitriding. We have seen where we have seen the simple nitriding process which is usually performed under the temperature conditions of the 500 to 600 degree centigrade. This is the Faraday zone for the steels. So, at this in this temperature range the nitrogen rich environment is created using ammonia, and which provides the nitrogen rich environment all around the component surface which is to be modified. So, the nitrogen content is enriched at the surface and subsurface layers. This is the reverse trend, because the nitrogen is to be introduced at the surface and subsurface layers. So, once the nitrogen has been enriched in the component to the desired level, which may be like 10 to 15% as well. So, this will be forming the various types of the iron nitrides. So, at the surface layer iron nitrogen content is more, so it forms the hard and brittle nitrogen layer, while in the subsurface layer nitrogen concentration is less. So, the other type of the nitrides are formed which are hard and stable and do not increase the cracking tendency much. But in case of the laser nitriding, basically laser is used here for melting the surface layers up to a very thin depth. So, very thin layer of the material is melted, and this is carried out in the nitrogen rich environment. So, the nitrogen introduced in the surface and near surface layers, and thereby it will be forming the iron nitride. We have also seen that if the steel is having the alloying elements like aluminum, chromium, vanadium, then these nitrides of these elements are harder and stronger, they are more stable. So, the effectiveness of the nitriding process is much better. Like in one of the typical cases where 13-4 martensitic stainless steel subjected to the laser assisted nitriding, when it is performed, we get the nitrogen concentration in the range of the 3 to 4%, and just after the laser nitriding we find that the nitride content of the nitrides or like the chromium nitride or iron nitrides at the surface layer is less. So, immediately after the nitriding, when the nitrogen is introduced in this range, the concentration or the proportion of the nitrides of the chromium and iron is limited. So, and therefore, due to the limited concentration of the chromium or iron nitrides, immediately after the laser assisted nitriding, it is required to perform the post nitriding heat treatment. So, post laser assisted nitriding heat treatment is performed. Say if it is performed for 6 hours at 600 degree centigrade, then this kind of the treatment helps in forming the significant proportion of the chromium and iron nitrides using the nitrogen which is present in this at the surface layers and near surface layers of the steel. So, the laser assisted nitriding will simply be increasing the nitrogen concentration near the surface layers, and subsequent heat treatment will be facilitating the formation of the required nitrides of the chromium or iron in this particular case. And similarly, if the nitride forming alloying elements are present in the steel, then effectiveness of this process will further be enhanced. And once these nitrides are formed at the surface, it will be increasing the surface hardness, will be increasing the wear resistance, and it also helps in increasing the corrosion resistance, fatigue resistance in terms of the mechanical properties. So, number of the benefits are exploited. In case the only difference here in the laser assisted nitriding with respect to the conventional nitriding is that laser is being used as a additional heat source for facilitating the introduction or introducing the nitrogen at the surface and near surface layers. Now we will be talking about the third approach of surface modification technique, where development of surface layers in form of the films, coatings or claddings is used for surface modification. So, this is the third approach of the surface modification. So, in this case, when we find that our component is made of a material which can provide the required support for the mechanical loading. So, normal mechanical load carrying capacity is offered by a material of which component is made. But if you want that either for increasing the performance of the component or for increasing the functionality of the component, if it is required that surface of such kind of the component is having a specific set of the properties which are actually absent in the normal substrate, then these kind of the properties can be achieved by developing a layer of the suitable material which can really offer us the properties which are desired at the surface for increasing the performance, maybe in terms of the mechanical properties, tribological properties, or any other property which is required for improving the functionality. So, the substrate may be good with regard to the ability to carry the mechanical load, but it may be having the poor properties in respect of like optical properties if they are required at the surface, or thermal properties if they are required at the surface. This may be in terms of the increased thermal conductivity, or what we want, reduced thermal conductivity. So, thermal insulation, there may be purpose of applying layer. There may be both the purposes of applying a layer at the surface, either increasing the thermal conductivity or increasing the thermal resistivity or increasing the thermal insulation. So, the loss, transfer of the heat across the surface can be reduced. It may also be desired to have the improved electrical properties of the surface layers. Electrical properties of the surface layer, or it may also be desired to have improved wear resistance, which may be in terms of the abrasion, adhesion, erosion or corrosion. So, if the substrate is not having the required set of the properties for improved performance or for improved functionality, then those kind of the properties are imparted maybe in form of optical properties, thermal properties, electrical properties, or tribological properties. Then it will be required that surface and near surface layers of the substrates are modified using the suitable kind of the materials at the surface. So, the substrate surface is applied using a material which can offer the required set of the properties in terms of the optical, electrical, thermal, mechanical, tribological so whatever kind of the property is needed, the suitable kind of the material is applied at the surface layer. So, a layer of suitable material is developed in this approach of the surface modification for improving the corrosion resistance, improving the wear resistance, for improving the electrical, optical or thermal properties. Now, how these layers can be applied? There can be different methods for the different mechanisms for applying such kind of layers. It includes like chemical reactions. There may be electrochemical reactions. There may be like welding using the partial or complete surface layer melting. There may be thermal spraying using either combustion method where the suitable fuel gas is burned, combustion method, or electric arc is used for thermal spray purpose. So, these are the various groups of the mechanisms or the approaches which are used for developing the suitable layer of the suitable material on the surface of the substrate. So, if we talk about the first the chemical methods, then chemical where chemical reactions is involved, like then electroless plating is one method, hot dipping is another, and physical and chemical vapor deposition PVD and CVD. These methods are very overlapping in nature, where surface composition is also modified or very thin film is developed at the surface of the substrate. Then we have the electrochemical based methods involving like electrolysis in electroplating method and anodizing. Then we have those approaches where surface layers are brought to the molten state and the material which is to be applied is also melted, and intermixing of the two leads to the development of the suitable layer. So, use of the welding processes or the welding methods. It can use the gas welding, it can use shielded metal arc welding, it can use the gas metal arc welding, it can use the gas tungsten arc welding, plasma arc welding. There are two variants, non-transferred plasma arc or transferred plasma arc welding. So, both these are the welding processes. And then we have like laser is also applied for this purpose. Laser cladding is one of the commonly used process for modifying the surfaces. Then we have third group of the process, which is known as thermal spraying. In case of thermal spraying, the material which is to be applied onto the substrate is brought to the molten or partially molten state, and then it is accelerated at a high speed towards the substrate, and then after impingement with the surface of the substrate, it gets solidified and forms a layer on the surface of the substrate for surface modification. There are two broad groups in this category, one which uses the combustion involving the burning of the fuel, gas and oxygen mixture for spraying purpose, and another is where electric arc is used for developing the heat. So, basically the grouping is based on the kind of the heat source which is being used. Here heat source is electric arc, and in this side heat source is the flame which is obtained through the combustion of the fuel gas and the oxygen. Maybe it may be acetylene, kerosene or any other kind of the fuel which can be used for the combustion purpose. The methods which are used in this category includes flame spray process. This is commonly known as oxy-fuel flame spraying, and then we have detonation gun, detonation spray process. There is a detonation gun, so that which is used for the spraying purpose, that is why it is called detonation spray process. And then there is one more the combustion based process which is called high velocity oxy-fuel spray process. In short, it is known as HVOF process, and this is known as D gun process, and this is the flame spray process. These are the combustion based methods, and in arc based methods there is a wire arc spray process, and then there is a plasma based methods where like a transferred plasma arc spray. Now, this may be carried out, there are two variants. This may be carried out in the controlled under controlled atmosphere or simple normal ambient conditions. So, accordingly it will be given the different names. So, the transferred plasma arc spray process or atmospheric plasma arc spray process, this is commonly used for developing the claddings and thick layers of the suitable material on the surface of the substrate, so that the required surface modification can be achieved. Now, as I have said, layer of suitable material is applied on the surface of the substrate. It may be applied in form of films, in form of coatings or in form of the claddings. So, in all these cases a thin layer is developed, however thickness may vary, and this grouping is based on the kind of thickness of the layer which is being applied for surface modification. So, when the thickness of the layer being applied is less than 10 micrometer, we normally call that the layer being applied is a film. Like PVD, CVD and very hard coatings, DLC like diamond like coatings are applied in form of films which are very thin. Then the coatings are slightly thicker and they are applied in the range of like say 10 to 1000 micrometer thickness, and for further greater thicknesses the claddings are used like greater than 1000 micrometer. So, this is a broad grouping, however, there is no hard and fast demarcating lines with respect to thickness for categorization of a layer in form of films or coatings or claddings. But in general, this is the kind of the range which is used in practice for grouping the developed layers for surface modification as a film or coatings or claddings. So, if we see the purpose for which films are normally used, these are very thin, like less than, these are thinner than the 10 micrometers. These are normally not used for non stress applications, primarily where like optical, thermal or electrical properties of surface layers is to be altered, like we want to have the greater thermal conductivity, or we want to improve the increase the absorptivity or reflectivity of the surfaces, or we want to increase the electrical conductivity, or we want to decrease the electrical conductivity. Accordingly, the suitable film of the suitable material will be developed. However, the thin films are also applied in some of the cases, like cutting tool inserts thin films of TIC or titanium nitride or titanium aluminum nitride coatings are applied in the cutting tool inserts, where the moderate level of the stresses will be acting on the surfaces. On the other hand, coatings which are thicker than the films are generally in the range of 10 to 1000 micrometer. They are used for increasing the surface layer hardness, increasing the wear resistance, increasing the corrosion resistance, or where moderate level of the stresses are acting. So, like increasing the wear resistance under the abrasion, erosion, adhesion, etc. So, for those purposes all these coatings are used. As far as the claddings are concerned, in case of the cladding, very thick layer greater than the 1000 micrometer is applied, and objective of this building up of the cladding is to have the thick layer, so that we can have a build up of the material for regaining dimensions. After the machining, we can regain the size and shape. So, for reclamation purpose, the cladding can be used. And another important application of the cladding is where the corrosion resistance is to be improved. Corrosion resistance is to be improved. So, a thick layer of the corrosion resistant materials will be developed on the surface of the substrate, and it will help us to offer the longer tribological life of the component. So, these are the general features and the properties associated with the films and the coatings. Now, we will see there is a broad grouping of these processes which will be offering the different thickness layers, but there is one more aspect with regard to the thickness and the material which can be applied in form of thick layer or thin layer and its properties. In general, higher is the hardness, lower will be the thickness of the layer which will be built up on the surface. So, very hard, like diamond like coatings having the hardness of like 1800 or 2500 HV, thickness of the coating will be very less, maybe like 50 micrometer or 10 micrometer as per the hardness. Like diamond like coatings will be developed in form of very thin films, but if the hardness is lower like 400 500 HV, then maybe we can develop a thicker layer in form of the coatings of 400 to 500 micrometer. And if the hardness is further lower, like austenitic stainless steel hardness of like 200 HV, about 200 HV, then we can have a very thick layer in form of the claddings of the austenitic stainless steel. So, softer is the material, thicker layers will be possible, while if the hardness is high, then we can develop the thin layers for proper and prolonged performance of such kind of the layers for the surface. Now, we will see the kind of processes which can be used and the thickness which is normally achieved. So, here if we have 10 to the power minus 5, 10 to the power minus 4, 10 to the power minus 3, 10 to the minus 2, power minus 1, 1, 10, it is in mm, and the thickness which is thickness of the surface modified layer which is achieved. So, if we go by the thickness, then the welding based methods like this will be somewhere here. The welding based methods will be there, they are used for very thick coatings like greater than 1 mm or 1000 micrometer. Then thermal spraying may be used in the band of like say 50 to 1000 micrometer for thermal spraying, and about 10 to 100 micrometer like chrome plating. On the other hand, like ion implantation is for very thin layer ion implantation. Nitrogen ion implantation is one of the commonly used method, and then CVD and the PVD. These are the kind of bands for CVD and PVD. So, there are wide range of the thicknesses which can be used for surface layers and the different category of the processes which are used. Basically, in this one we will be focusing on the welding and the thermal spray based processes. We have already talked about the ion implantation, PVD and CVD kind of the materials, where apart from the compositional modification, a thin layer is developed in form of the film for improving the surface properties. Now, here I will summarize this presentation. In this presentation, basically first of all I talked about the laser assisted nitriding, where we have seen that in presence of laser, nitrogen is introduced at the surface layers for improving the surface properties through the formation of the nitrides of the different elements which are present in the steel. And thereafter we have seen the basic approach of the building up of surface layers for surface modification and how it can be used for improving the surface properties. Thank you for your attention.